Hi everyone, my name is Henrik. I'm the founder and CTO of a small startup in Denmark called Family. I'm here to talk about cloud computing and how we use Amazon Web Services to host our solution. Just a quick word about Family. Family is an app for daycares. We help the daycare better manage the resources such as staff planning. We also help them communicate digitally with the parents so they can share images during the day and the parents can consume this information on their smartphones. If you want to hear more about Family, please come up to me during the conference. I'll be happy to share my experience both in technical matters but also in business if you want to hear more. So, let's get to the topic. Cloud computing. I thought a bit about how to present this, and I went with a kind of a case where we will have a web shop called, or website called ticket.com we want to develop, and we want to host it in the cloud. So this website, we want to sell tickets. But we also need an application for the people at the concerts to validate these tickets, to validate that they are only used once and that they are actually valid. These two parts of the system, they have two different characteristics. Our website with the web shop will experience high peak loads when the tickets are published, and the app should always be available. We cannot have any downtime so the people can validate tickets. So these are the two main characteristics of our system. And we want to solve it using Flow, of course, and then Amazon Web Services. I have a lot of experience with Amazon Web Services, and I will go through the concepts here, but a lot of the other cloud providers have the same concepts, they just named differently. To do the development, we'll use Docker. I guess many of you might know it, but otherwise I'll just explain it. Docker is a virtualization technology similar to Vagrant and VMware and the other, where you can create a whole setup with your configuration, your packages, and of course your source code, and you can put everything into an image called a container in Docker language, and you can run it. So you can create a setup on your development machine that looks a lot like the production machine, or is actually the same container that runs your production environment. We'll use GitHub for the source code, and then we'll use something called the Docker Hub to build these containers. So the ecosystem for the development process would be that we develop the platform on our laptop, we commit the code to GitHub, a hook in GitHub triggers a build over at the Docker Hub that builds a container containing our latest source code with our web server and all the configuration files, etc. And we can then use this container to run our production setup too. So this is super basic development. I won't speak more into that. I will rather spend the time on the production environment. So to get started, we need some DNS. We need to buy the domain. In Amazon terms, the DNS solution is called Route 53. In Route 53, you can buy the domain and you can host the DNS there. There are some benefits of using Route 53 for the DNS. Of course, it integrates very well with all the other Amazon services, so later on I'll explain more about the load balancing features. If you want to use that, you need to have your DNS in Amazon, but there are also a lot of other integrations. I'll get back to that later on. So we buy the domain, we host it at Route 53, and everything is fine. So now we need to put something on the servers. We need to take this Docker container and put it onto a server to host our environment. We use a system called Beanstalk for that. It's an Amazon service that handles all the deployment specifics about how to take the container from the Docker Hub and put it onto a machine, put it onto a server. So we use the Beanstalk for that. Again, I won't go into super details. I would rather spend time on explaining the concepts, and then it's quite easy to, when you look at it, to find out how to use them in specifics. And you're more than welcome to come ask me later on if you want specifics. Let's just spend a short moment explaining the different servers that you can buy at Amazon. The virtual servers are called EC2 servers, and you can get them in a lot of different sizes, ranging from the smallest one, which is the T2 Micro, with 1 core and 1 gigabyte of RAM. If you buy the on-demand price, that means you don't pay anything up front, you only pay an hourly rate. Then you'll end up paying around $15 a month for that. and you can go up to a very large instance also. My own philosophy is that to use a lot of smaller instances instead, because that means you can scale horizontally. You don't have to scale vertically if you start from the beginning by using small servers. Amazon also has what they call region and availability zones. This is an old map. I think, was it in the fall or in the winter, they launched a site here in Germany too, in Frankfurt, but this map shows quite well how they organized it. So you have regions which are like Oregon, California, Ireland, that's this physical locations or areas. And then within a region they have what they call availability zones. And availability zones are physical independent data centers with their own power supply, their own internet connection, etc. And to show this, we'll use this diagram through the rest of the talk. It shows the region EU West 1, that is Ireland, and we have 3 zones, zone A, B, and C, which are all different data centers. So let's start with a very simple solution. We have our website, we have the DNS, as you saw before. The domain resolves to an IP. The client goes through that IP to our web server, which is running the container, which Elastic Beanstalk has put onto the instance, and we see the sample site. This is just super basic setup, like many websites out there run on one server, no load balancer, no nothing. And this setup doesn't even have a database, so it's just very simple to get started like that. But to actually put some data on, we of course need a database. For that, we'll use MySQL, and we'll use Amazon's RDS service, which is a managed relational database service. And it's MySQL compliant. So the benefits of using that is that you get automated backups, you get encryption both in transit but also at rest, and you get automated maintenance. They operate everything, they handle everything for you. You just specify for how long a period you want the backups, when is your maintenance window, is it in the middle of the night on Mondays or what you want, and they will handle everything. So if we put that into the diagram, for me, taking things visually just helps a lot of understanding these concepts, so I will use this diagram a lot. But now you see we have a database also in the same data center. So now we have actually a live web shop. People can now buy tickets on this, and everything is stored in the database. So this is like very simple, basic setup. But it has a lot of problems because it can't scale, it's not highly available. What is, if the server dies, our website goes down, and the people at the concerts can't validate the tickets. So we need to do something about that. And to do that, we introduce a load balancer. In Amazon terms, it's called the Elastic Load Balancing. It's a load balancer service that goes on top of your web servers and distributes traffic to your web servers. It does a lot of things. It enables us to have high availability because we can use multiple web servers beneath this load balancer. It also enables us to scale because we can have 2 web servers or we can have 200 web servers. It doesn't matter, the load balancer just routes traffic to the healthy instances below. But it also helps us with, if we want SSL, it does SSL termination, so it encrypts and decrypts, so our web server doesn't have to handle that. Put into the diagram, it looks like this. So we get the load balancer on top of our web servers. It spans across all the availability zones, and for now we just keep it simple again. We have 1 server in each availability zone. And now you see that the DNS resolving is different than before. And if you want to use this feature, you need to use Amazon's DNS, because inside the black box called Elastic Load Balancing, Amazon is handling servers for you. So they need to register which IPs those instances have, so that the traffic goes to the load balancer and then onto your servers. And if you have a lot of traffic, then Amazon will just scale their load balancer without you having to do anything, and they'll add more instances into the load balancing part. And then they'll add the IPs to the DNS, and everything would work without you having to do anything. Sorry. But this raises some problems. If you just use default configuration with Type-3 Flow, and you use sessions, sessions would be based in the file cache, and since we have multiple web servers now, you can ensure that people go to the same web server every time. So we need to have a shared store for the sessions. The same goes with logging. It will log to a local file system, and then our log files will be spread over a lot of instances. And as I'll show you later on, our instances will come and go depending on load. So we need to ship the log files away from the servers as fast as possible. And uploaded resources, the same problem again. It goes to the local file system, and you can be sure that the next time the visitor comes that you have the file there. So we need to find a solution for these problems. But hopefully it's quite easy, or luckily it's quite easy. The sessions, you can just change the backend of the session to use a database or use a memory cache, and then all the web servers would go to the same place to look for these sessions. So that's pretty easy. Again, there's a product called Elasticache, which is a managed memory cache. You can either use Redis or Memcached. It's super easy. We use it a lot, and it just works. So that's not hard. The logging, there are a lot of tools for that. We need to ship the log files to a central logging services. You can either use a cloud-based provider you pay for, or you can host your own solution. Greylog is an open source logging solution. And Amazon also has CloudWatch, where they can store the log files. My opinion about CloudWatch right now is that it's still too early to actually use for production, because you can't search through the logs. It's a nice way to store your log files at Amazon, but it's very hard to do searches based on them. So we use Greylog in our company. The final one, uploading resources to the local to the cloud instead of having them on the local file system. The easiest solution if you use Amazon is to use their file service. It's called S3. And I'll just tell you a bit more about S3. It's a super nice service. It's the file and object store where you can just put all your files into, and you don't have to worry about disk running out of space or anything. You just pay as you go, and you pay for the space you occupy, and you pay for the traffic that you consume or your clients consume. It's very easy to use. It's super cheap. It's highly scalable, and it's very durable. Your files are replicated among 9 locations inside the region, so 3 places in each data center, and they have a very high SLA on not losing your files. And it's super cheap. I can't remember the prices, but it's very cheap. So if we look at the diagram again, and now the images, for example, the static resources, we can put them on S3, so the clients go directly to S3 to fetch those images. They don't have to go to our servers and put load on our servers for that. And we have fixed the problem with images stored on the local file system. So just a quick slide about how to use that and how to upload your resources. And I actually think in the next version of Flow, there will be some kind of support for it, right? Yeah. But for now, it's the way we did it is just using the native Amazon SDK. You install it via Composer, as you normally do with PHP packages. And then you have a client. You can call a put object method on that. You can specify what is the target bucket. Bucket is comparable to a folder. What should the name of the file be? And what is the source file on our local file system? And then you can put some metadata on it. And what you get back in the result is an object containing the link to where you put the file on S3. And you can decide if you want that file to be public available. If you do that, then you can just store that link in your database and use that to give to your clients so they can fetch the object directly from S3. And then we call wait until, so we ensure that the file is uploaded, and when that is done, we can delete it from the local file system and clean up. Again, if we look at the diagram as you saw before, images go to S3, clients go directly there, and we only need to serve the HTML documents, or if we host a REST API, it would only be the API calls that goes to our setup. So now to the fun part of cloud computing, the autoscaling feature. It's super nice feature that enables you to have a setup that is self-healing. So if instances die, they just fire up a new instance, set everything up for you, and put it into the load balancer. It also enables you to have a system that can scale based on metrics you define. That could be CPU utilization, network bandwidth, whatever you want. And say when we come above this metric, boot up 5 more servers. And you can do that infinitely. I saw speak with another guy. They had, in the night, they had 2 servers, and at the peak time of the day, they had 300 servers. And the system just automatically boots and kills servers. And you pay an hourly rate as you go, so you only pay for what you use. So if we look at the diagram here again from before, we have this 3 instances in each data center, in each availability zone. The load balancer, every 15th second that's configurable, it checks the health of the instance. So it checks, you specify that health check yourself. So you need to check the health of what is vital to your system. For this basic setup, it would be that we can connect to the database, for example. It doesn't matter if, for example, the web server in zone B, maybe Apache is running, but a switch has died, or there are networking issues that prevents the server from talking to the database, then that server is not healthy. You specify that health check, and the load balancer then handles removing servers from it if they are unhealthy, and adding servers if they become healthy again. So let's imagine that the server in zone A dies. Poof, it's gone. We don't know what happened. It could either be the physical instance it was running on that died. It could also be networking issues. It could be a lot of things. But it disappeared. Now within 15 seconds, the load balancer will do its health check, see that it's gone, and remove it from the cluster, or remove it from its configuration. So now the traffic will only flow to the 2 servers that we have left. The autoscaling would notice that. And if we had a rule saying that we want at least 3 healthy servers, the autoscaling would just fire up a new instance, Elastic Beanstalk would configure it, deploy the container, and the load balancer would detect a healthy instance is now available, and it will put it into the load balancer, and traffic will start flowing. So it's healing itself. And actually, we had a small breakdown the other day, and I was out running. I got the alarm on my phone that the system was down, or a server has disappeared. And then within 5 minutes, we were up running again with 3 servers. And in the 5 minutes, we were just running on 2 servers. So there would be only a third of our traffic for 15 seconds that noticed that a server has died on us. That is fine. And it's so nice as a developer or as a sysadmin just that the system fixes itself. But it could also be the autoscaling part that triggers based on metric you define. So let's say we have a metric that says if the aggregated average CPU utilization on the whole cluster comes above a certain threshold, we want to fire up more instances. That could be, for example, when we want to sell the tickets on the web shop and a lot of people comes in, then we could trigger this. And then the autoscaler would fire up new instances, Elastic Beanstalk would configure them, the load balancer would detect a new healthy instance is up, and it would put it into the cluster. So suddenly now we have 9 servers in 3 data centers instead, and now we can handle the peak load. Given that our database can cope with it. So now the web tier is scalable, it's highly available, so that's fine, but we have a problem with the database. What happens if the database goes down? The physical instance that the MySQL server runs on, what happens if that goes down? We have a problem. Oh yeah, now load is going down again, so servers are just shutting down. But we have the problem with the database. So that's why we enable the multi-availability zone, RDS feature, and that means that if we look at the diagram, it's much easier understanding here. What that means is that Amazon is replicating all your data to another data center, and it does this synchronously. So you are sure that every time you write to the database, it is written to both the data store in zone A and zone B before the client gets an OK. It's handled fully automatic, you don't have to do anything, and then you have a backup data in another availability zone. So, That means if the database in zone A dies, everything is automatically routed to zone B instead, and a new replica in zone C is created. So this is based on DNS, so there are 60 seconds or so of downtime where clients will still try to go to zone A, and then they will find out that the IP has changed and they will go to zone B. But it's okay, you don't expect your database to go down every day. We've been running for 2 years now and it hasn't happened to us yet. But if it does, we know it's automatically just moved on. So around a minute of downtime would be okay. So now the database is also highly available, or at least it's more robust than just having a single database server. But we still have a problem with load. What if a lot of clients want to read at the same time and our database can't handle that? We can also do something with that. Just skip this. So we can create what's called read replicas. A read replica is an asynchronous replica of your database. So again, let's assume that all our HTTP GET methods, they only read from the database. They don't have to change anything in the database. And then our HTTP POST, they write to the database, or they have to change something in the database. If we put that into the diagram with read replicas, it could look like this. So we have a lot of web servers, we have a lot of read requests coming in, and then we just choose a random read replica. Amazon handles the replica from the master server to all the read replicas. You can have as many as you want, and my experience so far is that the lag between data written to the master and replicated out to the read replicas is very low, like 1 millisecond or so. And then you can just fire up all those read replicas you want, and this gives us actually higher availability than just relying on a single database server. Because if a read replica goes down, then the web servers would notice it and just start using some of the other ones. So there are a lot of other services too that is very powerful, and this is the basic setup, like web servers, database servers. We have some asset stores, but there's also a lot more to having a modern web platform. That could, for example, be queues. So Amazon SQS is a managed queue solution that is very scalable and it's super cheap. So you can send messages to the queue and you can consume those messages as fast as you want. Things you can use a queue for example, if you want to send out email newsletters, instead of having your client to wait when the server generates thousands and sends thousands of emails, you can put a message into the queue and you can have a worker handling that and just sending out those emails. You can do the same thing if you have some reports that are very heavy to generate. You could put that into a queue and just tell the client, okay, thank you, I'll generate the report and tell you when it's done. Some of you heard my talk last year about event handling or event-driven architecture. We use that a lot in our company, and we use the SQS to distribute those events to the different parts of the system. So every time something happens in our system, we publish an event to the SQS, and we have different listeners or different workers that then consumes those events. Put into our nice diagram, it could look like this. We have SQS out here on the side, which is a managed solution. You don't have to think about it. You can just publish your messages, and then you can have a worker, you can have 10 workers, you can actually auto-scale your workers depending on the queue size. So if we have a lot of messages in the queue, we could say we want more workers. All those things you can do, but basic is that you can just have your workers do the hard work, and then you can have your web servers serve new clients instead of having to generate all those heavy load issues. So now we're starting to have a very advanced setup that can handle a lot of situations. But there is more services you can put on this. Amazon has a service called Simple Email Service. If you have tried to handle large-scale email sending, you will also know that it's quite hard to get a good delivery. You have to have anti-spam agreements with the main providers, Gmail, Yahoo, Hotmail, and so. You need to have the right signing of your emails. All this is handled for you if you use their service. They have all these anti-spam agreements. They have the IP addresses of their email servers are whitelisted on a lot of places. And they do, if you use the DNS solution at Amazon, they also do the DKIM signing for you. You don't have to do anything. And you just get very high delivery rates. And it's super cheap. If I remember correctly, it's something like $0.50 for 1 million emails or something. It's ridiculously cheap. And again, it's very easy to use. If you install and configure the client using Composer, there's just a client you can call and send email method, put in who should have the mail, what is the content, etc., and then you can just send the email. It's super easy. You could also do push messages in the same way. Amazon SNS, Simple Notification Service, is a service that can push to iOS and Android, so you don't have to set up a server that is authenticated with Apple and Google. You just call a publish method on the client, and you can send push messages. Again, and this, I remember, is $0.50 for 1 million push messages. It's something like that. It's super cheap. And it's very easy to use. Amazon CloudWatch is a monitoring solution that all servers, all services at Amazon, they publish metrics to this CloudWatch. So you can go in, this is just a random screenshot from one of the servers where you can see CPU and you can see network, disk I/O and stuff like that. But all the metrics from the different services go into this one solution. So for example, the queue service I told you about before, the queue length goes into this, the request going into the queue goes into this. So you can use the Amazon CloudWatch to monitor your performance, but you could also use it to trigger alarms. So you can say, if the CPU usage go above a certain threshold, send me an alarm. And it's also what the Autoscaling uses to trigger these Autoscaling features. So you can, whatever is in CloudWatch can be used for doing Autoscaling. And the CloudWatch also, you can log custom metrics. So if you want some crazy solution where you log some crazy, if it rains, I want to scale more servers or something like that, you could actually do that. Then you had to log, if it rains, into CloudWatch and set up Autoscaling to look at that metric. So there are a lot of more services. I don't want to go into them, but some of the more exciting ones for a platform like Top 3 Flow could be the CDN, the CloudFront solution. It's called CloudFront. They have all these regions, but they have more data centers than that they use for CloudFront. So you get a CDN where you can get low latency delivery of static resources to your clients. And then there was this Elastic Cache I told you about earlier on, the managed Redis or managed Memcached, and a lot more. They have video transcoding services, they have NoSQL databases, they have a lot of different services. So when I talk to people about Amazon, a lot of times people think the pricing is very complex, and I totally agree with that. It's super hard. They charge an hourly rate for the service. That is very easy to understand. You can just multiply with the amount of hours in a month and you get the monthly bill. But they charge for I/O requests, they charge for DNS requests, they charge for a lot of random stuff. But my experience so far is that 99% of your bill is predictable, or maybe 95% is predictable and 5% is unknown. So I've tried to make a small example here. Let's say we want to start this ticket.com. We want an advanced setup, as you saw here, but we just want it as cheap as possible because we don't have that many clients in the beginning. But we want to start out with such a setup because if we have, for example, have 2 servers in a load balancer, and that process is very smooth, we can deploy to that with ease, then having 200 won't change anything. And I've made this small calculation. So 2 servers are $30, the load balancer is around $20, and MySQL with failover is $30, and then 1 read replica is $15, and then the file storage, the DNS, the emails, the push messages, etc., you can do that for $5. So you end up with $100 a month, and you will have a setup that can actually handle quite some load, and when you are ready to scale more than that, your setup is ready. You can just change this auto-scaling to say, I want 10 servers, 200 servers, whatever, everything is ready for it. So if you start a new project and you want to use the cloud, my recommendation is start with more than one server from the beginning, because all the bugs that comes with having more than one web server, you get those fixed in the beginning when you don't have that many customers or that many clients. So a bit about my experience in using Amazon Web Services. We've used it from the beginning, and I really love it. And some of the reasons why I love Amazon Web Services is it's fairly easy to get started, and then I put in with a very advanced setup, because I know it's not as easy as some of the other cloud providers, but when you get up beyond those first small problems you get, it's quite easy to have such an advanced setup as the one I've explained here. And then all the other services that surrounds the core, like the core virtualization servers, those are so valuable and they are so easy to use and they are cheap. So you don't have to spend time setting up email servers, push messages, queues, cache, etc. You just need to focus your time on your business or the development of your core business. And then auto-healing, auto-scaling, that's just awesome. Yeah, as I told you about before, that the system breaks and fixes itself without me having to do anything is just nice. I only get a notification that it happened. And again, the final thing is that I really feel confident that we can scale horizontally. We can scale massively if we have to, because we can just add more servers horizontally instead of increasing vertically. So this talk is called Embrace the Cloud. So I also want to talk a bit about other services that you can use outside the Amazon. This is some of the services we use in family right now. We actually use more than those, but these are the ones I chose to highlight. And it's so cheap using those services instead of having to develop things yourself. We recently started using the one called Intercom. I won't go into too much details, but it's a system that enables you to have live chats with customers. It enables you to send very nice user-generated custom emails to your customers based on things like customers who signed up 7 days ago that haven't used feature A, send them this email or send them this message inside the app. It's just plug and play and we have that. Sentry is a hosted exception logging framework. Then we don't need to handle, have our own logging solution for that. And again, yeah, use all those services. They're not as expensive as the development time you would use to do this yourself. And that was what I have to say about cloud computing. Thanks for listening.
All right.
I guess there are questions.
Yes, we have time for a couple of questions. So if you want to know anything about cloud computing, I guess, shoot. It's now or never. Okay. Just a second. Could you raise your hand again, please? Thanks.
Hi, just one question. Do you have one in your company who actually knows everything and has the complete overview of all the services and how everything works, or do you just leave that completely to Amazon and just say, yeah, works, we don't know, but yeah, it does?
I would argue that I know how our system works and I could move it to another provider if I wanted to. So that's my area. But yeah, I'm not quite sure I understand the question exactly, because you need to, of course, you need to have your Docker containers set up with the correct configuration. You have to tune them with if you have performance problems and stuff like that. You can't just look away from that. So you need to put the things into the container that you need to run your business. But then deploying the container, I'll let Amazon handle that, because there's nothing about servers there. I don't want to know exactly how they deploy the container. As long as they do it and it works. And then the auto-scaling, the load balancer would detect a problem. If one of the instances dies, it would detect that and just remove it. And then it's so cheap just firing up new instances. So instead of trying to debug something on a server, it just fires up a new one.
Okay, thank you.
Additional questions? One and one. Okay.
So if you're testing your application or debugging, are there possibilities in Amazon to test your event queue, your push messages? Is there something you can call, okay, I see this is my stack and I can see this event, this event, this event, this push message when I'm developing? Is there any possibility to have a look at that?
Our development is actually completely separated from Amazon. It runs completely local, and we have just developed like an interface for the Amazon push service. So when we're in development mode, we just now send a push message to this user saying this, for example. So, and the same goes with emails. We just put it into the log instead. So as a developer, you would go there. So you can actually develop without internet connection, and our system will still work. But there are regarding push messages, they have a solution, because if you're in sandbox mode, as it's called with the iOS push messages, they have a sandbox server where you can also test push messages.
Okay, thanks.
Can you tell a little bit how your development process looks like? Because when you upload to Amazon, you have those Amazon interfaces, but when you develop maybe offline, even at home, you not always upload there, or you not always connect there.
Yeah. The emails, we just have an interface that goes to the log. The push messages, the same. The queues, actually, we've just created a solution so that instead of events being published asynchronously and handled asynchronously in our development environment, they are handled synchronously, so we don't have to have a queue set up on our development machines. But of course, you can argue that that is not as similar as the production environment, so it would be better to have a queue solution on the development platform as well. My experience, though, is that it's a pain to develop with a queue, and then you have to fire up the queue, and then if an error occurs, and then what is in the queue and stuff like that. So it's actually easier just handling things synchronously in the development, and it hasn't been a problem for us that those two things are separate or are different. Then there are the resources. That's actually the biggest problem. Right now, we just store it locally when we're in development and use a local URL for it instead of uploading it. So all those things that in production connects to Amazon, currently we just have some local solution for that.
Talking of an existing Flow application that might be moved to Amazon Web Services, what is the recommended way to get started if you don't have much experience with services like AWS?
First, I would say try to create a Docker file that runs your setup, so that you have this container that runs your setup as it is now. You can do that on your local machine and test everything. Because when you have this container, it is very easy for you to move it to the cloud. Amazon has actually a lot of different ways to deploy code. They also have a service called Code Deploy, I think, that can take code from GitHub and some configuration files and put it directly onto the virtual machine, etc. But I prefer the Docker solution. So I would create a Docker solution that could take our current setup or your current setup and put it into this Docker container and then runs everything inside that. Then I would create a load balancer and then just one instance. And then it seems crazy to have a load balancer for one instance, but then you're ready to later on start to create more instances beneath the load balancer. So I would put the container in the Elastic Beanstalk service that then puts it onto an instance, and then I would use the Amazon RDS if you're using MySQL, and then just get the setup running smoothly on one server with one database, and then start from there. Then find out, okay, move our sessions to Memcache, move our resources to S3, and then do all those things, but keep one server. And then when you think you have checked all the pain points, then you can start trying out with multiple servers. So it is doable.
Questions?
So, hi. Don't get me wrong, but it sounds a little bit too good to be true. I would be interested in some problems you had that you didn't anticipate, if there were any. In
the beginning, we had problems with having multiple web servers, so the session thing and the resources and stuff like that. Also, even though you try to upload things to the S3 files, for example, then if it takes a short while, that's why you had to wait until we didn't have that in the beginning, so we could actually have clients that tried to request the file that was not fully uploaded and stuff like that. But I think it's minor problems actually. Yeah, I don't know exactly what more to say. Of course, there have been also performance problems with configuration files. For example, the smallest instance only have 1 GB of RAM. So the default Apache configuration has, like, if I remember correctly, 150 workers or something like that. So also that was a problem. We ran out of memory, but then we fixed that. But sure, of course, there are a lot of problems, and I think it would be different for each setup than what you run into.
We have time for one more question, so if there is any, speak up now, please. Oh, yeah.
So as you said, it's super cheap with Amazon, that's great, but do you expect that it stays that way?
Of course it'll get more expensive when you use more resources, and I know Netflix is running in Amazon, I don't want to pay that bill. But I think it will stay cheap, yeah. But I don't know, but of course, I don't know later on if it would get more expensive, but I don't think so. I actually think it's quite cheap. Yeah. Yeah, it's getting cheaper. If you can use larger instances, then you get also maybe a bit better price, and you can start to. They have the prices I showed you was on-demand prices where you pay an hourly rate. You can actually also they have you can what's it called? You can pay an upfront fee, and then you have the server. Reserved instances. You say I want to use the server for 3 years, and then your hourly rate is very low, but you pay a large upfront fee, and then you can get like 50% discount or something like that. If you want to say I want this server for 3 years. And then there are a lot of cost optimizations also. But again, to us here in the beginning, what is most valuable is that we can just iterate very fast on our setup. We can do everything ourselves. We can fire up new servers if we want to test something out. We don't have to wait for someone to do it. But it's also, of course, a privilege that we can do that ourselves. But for now, it's much more important for us just to be able to run fast and try a lot of stuff than what the exact bill is, as long as it's not way too expensive.